join us as we start. Madam Faustina, welcome and good evening.
Thank you, sir. Good evening. How are you?
Thank you. Yes, so let me share my board with you. Just a minute. So this is 2023 GCE paper 1, of course. So we have solved so far question 1 up to question 20. So today we'll start at question 21. So today we'll start dealing with the 21. We solved question 21, right? Madam Faustina, were you there? I think 21 we had solved it. 21 we had solved it, yeah. So mean that we start at 22 because I have remembered we ended on the part where we are discussing about calculus, where I explained about the calculus 1, calculus 2, and calculus 3. I just explained the nutshell, of which we are dealing with the calculus 3 about integration. So that's where we're going to start from, which is question 22. Question 22a, which reads as follows: integrate. So those who are writing, please, you can write. I'm sure most of you have this paper. Integrate 3 squared minus 5x plus 9 over x raised to 3 with respect to x. So this is how the question was. This is how the question was. So the question is demanding us to integrate. Okay, very simple. So remember to say last time I differentiated the term integration and the differentiation or the derivative. Okay, and where we ended, we are saying if at all we have been given, for example, a term which is y is equal to ax raised to n, to integrate with this symbol, okay, the symbol of y, we simply means that we say ax raised to n power plus 1 over n plus 1 plus c. So let me make a summary with this formula. So in short, when we are using this formula or when we are integrating, we just need to add the exponent or the power. We need to add 1. Okay? The sum that we are going to have, we need to write it as a denominator. So mean that we'll be dividing by that sum. We need to appreciate this concept. Okay? So now, when we come back to our question here, I'll first take 3x squared. 3x squared. Okay? If we want to integrate 3x squared, we first need to ask ourselves to say, what is the power that we are having? The power is a 2. So from this 2, we shall add 1. We'll say plus 1 over the same thing which is acting as a power here. We need to bring it as a denominator, which is 2 power 1. Okay? So which is the first expression, which is 3x squared. And then I'll bring now negative 5x. So negative 5x, it's the same as negative 5x raised to power 1, since it's just negative 5x. So it means that there is always a power 1 there. So with this power, of course, we shall add the plus 1 over 1 plus 1. And then now we have plus. Remember now, this one, let me explain this one properly so that you can appreciate it. When they say we have 9 over x raised to the power 3, this expression under indices, it's the same as 9x raised to power negative 3. Okay? This is because there's a rule which says that if you have a raised to power n, this expression is the same as 1 over a raised to power n. So this is a rule under indices. Okay, it's a rule under indices. So mean that if we have 9 over x raised to 3, it's the same as 9 times x raised to negative 3. So that is this expression. So mean that we are going to have 9 x raised to negative 3. As usual, we shall add plus 1 over negative 3 plus 1, and then plus c. So when we are integrating, we always need to add a constant c. Okay, that is a rule that we need to obey. We always need to add a constant c. When you leave out a constant c, it means that your calculations are wrong. So before I go any further, maybe let me pause here. Is there anyone with a challenge? Anyone with a question for me with what we have done so far? Madam Monida, do you have any question for me?
Sir, as for me, I think I would just need to revisit the whole topic.
Okay. All right.
Yes,
Okay.
but I'm trying by all means to understand.
Okay. Okay.
Yes.
Okay. How about others? Is there anyone with a question? Yes, Madam Faustina. And then we'll go to Madam Grace.
Hmm. So
Madam Faustina, sorry, I can't get you. I can't get you. Try to check your network. I can't get you.
I was saying I didn't get your explanation on this 9 over x power 3. My network has tripped.
All right. Okay. No problem. Okay. No problem. I'll repeat my explanation. And then I'll go to Madam Grace, and then I'll go to Mr. Levy. Yes, Madam Grace.
I think it's just the same. I don't even have a specific point where I can say repeat from this because just repeat in history.
Okay. So you are saying this the same concept which Madam Faustina has highlighted? Oh,
Yes.
all right. Okay. I'll clarify. Yes, Mr. Levy, your hand is up.
Yes, sir. Due to the network here, I had missed certain things that you were explaining, so I'm a bit behind.
Okay, no problem. I'll provide a nutshell over the summary.
All right.
Okay, let me go back again. This principle is very simple. It's a very simple principle that we need to appreciate. Okay, so here what we are doing is maybe let me do this. Let me write a number here. Let me write 3x power 2. Okay, let's integrate 3x squared, 3x power 2. So to integrate 3x power 2, what we are saying is we need to write the same 3x power 2, but to the power, we need to add plus 1. Okay? So we add the plus 1. When you add plus 1, the same exponent that you are going to have, which is 2 plus 1, will be also the denominator, which is 2 plus 1. Okay? When we simplify this, the answer will be 3x raised to 3 over 3. So now, in a nutshell, I want us to do this activity. Maybe that's when we can appreciate this concept. Okay? I want us to do this simple activity. Okay? Let's try to integrate, um, I'll say 2x raised to power 5. Let's try to integrate this. Okay? So mean that we're going to have 2x. So if we try to integrate this, okay, Bill, I've seen your hand. So if we try to integrate this, we are going to have 2x power what? Who can tell me the power? Who can tell me the power? That will be there. Yes, Billy.
It will be 5 plus 1, which is 6.
Which is 6. Okay? Thank you for that response, which is 6. So I'll write a 6 there. Okay? What else am I supposed to write? Is this my final answer? What else am I supposed to write? I've seen your hand, Billy, but I'm looking for another person to try. Yes, Madam Maria.
Sir, you are saying what else are you supposed to put as a denominator?
Yes.
Okay, on the denominator you are putting 5. The same denominator on top. The
Okay.
5 plus
5 plus 1, which is a 6, right?
yes.
So mean that we have over 6 there. Okay? So mean that we have integrated. Of course, if you want, we can now reduce this because there's a number that can go into 2 and 6 without leaving a remainder, of which that number is 2, where we'll say 2 into 2, it's 1. 1 times x raised to 6, it's x raised to 6. Over 2 into 3, it's 3. So this is our final answer when we reduce the expression. Okay? Yes, Billy.
Yes, sir. Sorry. I want to ask.
Mhm.
This one you are saying you integrate, and the other one that we did, it was last week. You are saying that differentiate. So differentiate is different from this one.
Yes.
So in differentiation, we said that, like for example, here where there is 2x to the power 5, we were multiplying 2x, or we are multiplying 5 times 2. So in this case, us we are not multiplying when we are integrating.
Yes.
All
So
right.
that one, Billy, it's dy by dx. We are differentiating, or we are finding the derivative. So that one I said it's purely calculus 1. Remember I said there's calculus 1, calculus 2, and calculus 3. Of course, when you go deep with the beauty of numbers, there's also other calculus, calculus 5. Calculus keeps on building up. Okay? So now with calculus 1, remember we are also subtracting. But with calculus 2, which is integration, we need to add. We need to add. So that's a summary which I can use to explain on that point. Are you okay with that, Billy?
Yes, sir.
Okay, wonderful. Let's have another exercise, okay? Or another activity, I mean. Let me write, me use red. Integration of 5x raised to 3, okay? 5x raised to 3. Who can tell me the answer? I want someone to tell me the answer here. Who can tell me the answer? Who can try? Madam Rachel, are you there?
Yes, I'm here.
Yes. What do you think here?
I think, although I'm a bit behind with this topic, but I'll try.
Okay.
It will be 5x to the power 3 plus 1,
Mm-hmm.
and then over 3. Is it 3 plus 1 also down there?
Okay.
Yes, and then I'm sure it will give us 5x to the power 4 over 4.
Very good. As simple as that. As simple as that. So it simply means that you have integrated. Okay. But of course, with integration, let's not forget plus C. Okay. When we are giving our final answer. Otherwise, this is how we are supposed to integrate. Is there anyone with a question for me so far? Okay. Billy says he's okay. Mr. Levy, are you okay? Mr. Levy, give me a feedback. Are you okay? How about Luboto?
Oh,
Remote?
Yes, I'm okay.
Okay, wonderful, wonderful. Okay, so now if we are okay with this concept, let's go back to our question. Okay, let's go back to our question now. After providing this background, okay? So remember now, the first expression here, it is 3x squared. Now with 3x squared, what have I done with this 3x squared? I've said we add 1 to 2. So we have 2 plus 1. Okay? The same 2 plus 1, we said over 2 plus 1. Minus, we have 5x. 5x simply means that it's raised to power 1. Okay? So we also add plus 1. Everything 1 plus 1. And then plus. The other term now, it is 9 over x to the power 3. So this term now, which I was explaining, to say 9 over x to the power 3, it's very hard here to add 1 to the denominator. Where are we going to put another over 3 plus 1? Okay? It will be too involving. That's the reason why I said, let's use the principles of indices, the rule of indices. What does the rule of indices telling us right now concerning this type of a fraction? Rule of indices says that if you have, for example, a number which is 2 over a, this 2 over a is the same as 2a raised to negative 1. Okay? So in short, when you have a fraction like this, it's the same as you write 9, and then the denominator, you write it but raise it to the power a negative number. That's the reason why I'm saying 9 over x raised to 3 is the same as 9x raised to negative 3. That's the same concept there. We need to appreciate. Okay? So here, for me to move from this stage going to this stage, I've not integrated, no. I've just written the expression in the other form. That will be easy for us now to integrate. Okay? So now, since now we appreciate to say 9 over x to the power 3 is the same as 9x raised to power negative 3, we now need to jump into the integration. But before I do so, I want to get a clarity. Are we now okay with what I've explained? Madam Faustina, give me a feedback. Are you okay? Okay, Madam Faustina says she's okay. Madam Grace, are you there? Even you had a challenge at this point? Give me a feedback. Okay, she says she's okay. So now, after we have appreciated this conversion where we are writing 9 over x to the power 3 as 9x raised to negative 3, let's now start integrating. So now we will say to the same power we'll add plus 1 over negative 3 plus 1. Then let's not forget plus c, this part. So having done this now, just a matter of us simplifying. Okay? Let's just simplify now. So we'll say we have 3x power 3 over 3. We are now adding minus 5x power 2 over 2 plus 9x power negative 2 over negative 2 plus c. With what I've written, is there anyone who's behind? Is there anyone who's behind with what I've written? Okay. If we are okay, let's continue. So now mean that at this stage, we are just supposed to simplify. Okay. Hope you are writing in your book. Hope you are writing. If at all I'm too quick, please raise up a hand. Update me if at all I'm too quick. Yes, Madam Rachel.
Sorry, sir, it was just a mistake.
Oh, all right. Okay, no problem. Okay. So at this juncture now, we can simplify. You can agree with me to say these 3 and these 3, they can cancel each other. Okay? So mean that we're going to remain with x raised to 3 minus 5x squared over 2. So remember here, 5 and 2, we are not going to divide anything because there's no n number that can go into 5 and 2 without leaving an remainder. Of course, apart from 1. Apart from 1, there's no any other number. So we'll leave it the way it is. Okay? And then here now, let's deal with this positive and this negative. Okay? Where we'll say positive divided by negative, the answer is a negative. Okay? So mean that we're going to have negative 9 over 2 x power negative 2. In fact, here even on x power negative 2, we can rewrite this one as well. Remember, we said if we have 9 over x power 3, this is the same as 9 x power negative 3. Have you seen that? I commented this one, okay, about this part. So meaning that if we have 9x power negative 2, it's the same as 9 over x power positive 2, x squared. So this simply means that if at all I want to kill this negative, which this power negative 2 negative, I can write it in this form, where I'll erase x power negative 2, and then I'll write it down here at x squared, like that. So when an expression comes down, okay, when we write it down, the negative, okay, if at all the power was a negative, it will become a positive, like that. And then I'll say plus a c. Let me erase this part. I just use it for explanation purposes. Okay. So with where I've reached now at this stage, is there anyone with a question for me? Is there anyone who's behind so far? Any question for me? Mr. Tembo, do you have any question for me? Are you okay?
Yes, I'm fine, sir. Thank you.
All right. Okay. So if at all there's no any question, then this is our final answer. We are done with the calculation. So now with this type of a question, I'm challenging you. Try to revise. There are two terms that you are going to find. It's either it's dy by dx, which is calculus 1. Calculus 1, I had explained it on the previous video. Try to find time to watch that video. Now with calculus 3, they use the term integrate. Okay? So when you are integrating, you need to add the power with 1. The sum that you're going to get, you need to write it as a denominator. Then you are home and dry. Then don't forget plus C always. Yes, Madam Rachel, your hand is up.
So how did you come up with 9 over 2x to the power 3?
Okay, so here I've just written this. So remember we have, okay, let me just get 9x power negative 2 alone. Okay, so here initially I said if we have, for example, 9 over x squared, if we have 9 over x squared, if we write it, it's the same as this part which I'm having 9x power negative 2. Okay? Remember, I had explained it when we had 9 over x power 3, where I said this is the same as 9x power negative 3. These are the rules of indices. Okay? Under indices. Remember, indices, this is the very beautiful topic in mathematics that helps us to understand powers, how to deal with powers. Okay, so mean that if at all there is a challenge on the powers, I can also challenge you to just visit indices and look at the properties of indices. Okay, so on those properties, one of the properties deals with the negative power. Okay, the negative power. where I've said if we have 9 over x power 3, it's the same as 9x to the power negative 3. So mean that even the opposite is true. What opposite? If I say 9x power negative 3, it's the same as 9 over x power 3. So now here we have 9x power negative 2. So it's the same as 9 over x power 2. Okay? So that's the reason why I've brought down this x power negative 2. I've brought it down as x squared here, like that. Madam Rachel, are you okay with my explanation? Madam Rachel, give me feedback. Are you okay? Are you okay with what I've explained? Madam Rachel, unmute your speaker. Okay, she says she's okay. Maybe there is one or two who are still interpreting about this rule. Is there anyone with a calculator here? I know this is paper 1, but there's something which I want us to prove so that we can appreciate to say this is indeed true. Anyone with a calculator? Is there anyone with a calculator? Give me feedback. Okay, Madam Faustina has a calculator. Now let's do this. Let's try to understand if 2 to the power negative 1, it's the same as 1 over 2. Let's try to establish this so that we can come up with a conclusion. Okay? Or maybe, let me do this. Instead of power negative 1, let me raise it to power negative 3 or power negative 2. Okay? And let's see if at all you are able to appreciate power negative 1. If at all you are able to interpret to say 2 power negative 1 here is the same as 1 over 2. So 2 here, it means that it's raised to the power positive 1 in short. Okay? We have power positive 1. So now, if we have 2 power negative 1, Madam Faustina, try to use the calculator. Okay? Try to use the calculator. Do you know where to place power negative 1? Madam Faustina, give us a feedback.
On my calculator here, it shows, I don't know if it's here where there is x to the power negative 1.
Yes. So right.
Yeah, I've done that.
And then what is your answer on the left-hand side?
It's giving me 0.5, which is
0.5.
half.
Okay.
Yes.
How about if we divide 1 divided by 2, what's our answer?
It's still giving 0.5.
0.5. So mean that this rule is very much correct. Have you seen that? So here I will just trying to show you to establish by using a very simple numbers so that we can come up with a conclusion with complex numbers, or if at all we are dealing with letters, the rule remains the same. Okay, so this rule we need to appreciate it, because sometimes they can also bring it as the first question under paper 1, where they are telling you to simplify. The examiner likes doing that. Okay, so we need to appreciate this pattern, this rule. And let's see if at all there is any question for me before I go to question B. Is there any question for me? Any question for me where I need to clarify before I move to another question? Okay, if at all there's no question, then let's move to question B. So question 22B was like this. We are given, this is under quadratic graph. Okay, we are given an x or y plane. Then it's like this. Then this is y is equal to x squared plus 2x minus 15. then we have A, we have B, and we have C. Of course, this is an X or Y plane. X or Y plane. Okay, this is an X or Y plane. Now, what is the question requiring us to do? Okay, the question wants us to find, we do this. The question wants us to find the A or Roman numeral I, the coordinates of B and C. And then question 2, the question wants us to find the minimum value of Y, like that. Very simple. Okay. I remember teaching this as a topic to you guys. So I'm sure we are just revising here. Okay. Those who can remember. So to find the value of B and C, what we are going to do is the value of C, you can agree with me to say it's very simple. The value of C. The value of C is very much simple. Okay. Even the value of A and B is as well very simple. And by the way, this is 15, not 5. Minus 15. Minus 15, not minus 5. Okay. So to find the value of C, remember C, it's along the y-axis. Okay. Maybe let me try and pose it as a question. Anyone with an idea? For us to find C, what are we supposed to do? Lowoto, what do you think?
We're supposed to
Yes, Lowoto, go on.
yes, so we're first supposed to start with so I failed to put my words together.
Okay. Okay, no problem. No problem. Who can try? Who can try? Madam Wanida, what do you think?
I think aren't we supposed to look for the products first?
Look for the product. Not really. Not really.
As in, guy, I don't even know how to explain it.
Okay. Let me enjoy it. Let me enjoy it. But before I enjoy it, I want to highlight this. Remember, we are drawing closer to the exam, guys. So let's start revising. Let's start revising. Okay? Let's start revising. Let's create time, okay, for revision. Because these questions, they are very simple. I've said the value of C is very simple. Why is it simple? Remember, C is along the y-axis. What are the characteristics of coordinates along the y-axis? Okay? Before I talk about the characteristics of longitude of coordinates, characteristic of coordinates along the y-axis, I said to say the other name for y-axis it is x is equal to 0. Okay? The other name for y-axis it is x is equal to 0. The reason being is because the x values along the y-axis they are zeros. So meaning that the characteristics of coordinates along the y-axis is that they always start with a 0. The x values is a 0. So meaning that the coordinate C, if we look at the coordinate C, it is 0, y, because it's along the y-axis, where the value for x is 0. Now, since we know the value of x that is 0, then where there is x, we shall put a 0. Okay? Where there is x in this equation, we shall put a 0. So mean that to find y, we say y is equal to 0 squared plus 2 times 0 minus 15. Where we say y is equal to 0 squared is 0 plus 2 times 0 is 0 minus 15. So y is equal to negative 15. So meaning that the value of y here is negative 15. But remember the question is saying we find the coordinate. So we need to give our answer as a coordinate. So we shall say therefore, okay, the coordinate of C, it is 0, comma, negative 15, like that. So this is the coordinate of C. Anyone with a question for me before we go to the coordinate of B? Because the question is saying we calculate the coordinate of B and C. I started with C. So now we go to B. Anyone with a question on how to calculate the coordinate of C? Who is behind? Can raise up a hand. Anyone who is behind? Mr. Levy, are we moving at the same page? Levy, give me a feedback. Are we moving at the same page? Are you okay? Okay. Says he's okay. Madam Mwanida, are you okay with what I've explained?
Yes, sir. I'm okay.
Luoto, are you okay with what I've explained?
Yes, sir.
All right. Then let's go to the coordinate of B. So remember, whether it is B or A, it's the same explanation which I'm going to use. Whether we are calculating for the value of A or the value of B. So the value of A and B, we can conclude here to say this A and B, they are along the x-axis, as you can see. Okay, they are situated along the x-axis. And the characteristics of longitude or coordinates, the characteristic of coordinates along x-axis is that the y values is always a 0. That's the reason why we say the other name for x-axis, it is y is equal to 0. Okay? So this simply entails to say, when we go to this equation, where there is y, we shall put a 0. So meaning that we are going to have, let me do this, I'll solve it from here. Since we have y is equal to x squared plus 2x minus 15, then we are saying where there is y, we put a 0, then we shall say 0 is equal to x squared plus 2x minus 15. Of which 0 is equal to x squared plus 2x minus 15 is the same as x squared plus 2x minus 15 is equal to a 0. Okay? So this is now a quadratic equation. This is now a quadratic equation. What have we done so far? What we have only done is that where there is y, we have substituted it with a 0. Why doing so? Because at A and B, the y values are 0. If at its coordinate A, we shall say it is x, comma 0. Coordinate y, it is x, comma 0. In fact, for coordinate A, it will even be negative x since it's on the negative part. Have you seen? Because if you draw the x or y plane, starting from the origin, going this side, these are the negative number. So A, it will be negative x, comma 0. B is positive x, comma 0. So meaning that our major aim right now is to identify or to calculate the value of x and the value of negative x. That's what we need to appreciate right now through a quadratic equation. So before we solve a quadratic equation, maybe there's someone who is behind. Let me pause here. Yes, Mr. Levy, your hand is up.
You were explaining something which I didn't get. The network was not okay just from the beginning.
Okay. At the beginning, I highlighted to say, when we are looking for the value of A and B, we first need to acknowledge to say A and B, they are situated along the x-axis. So now the fact that they are found along the x-axis, it tells us to say the y value is a 0. So since the y value is a 0, wherever there is a y, we shall put a 0. So now we have x squared plus 2x minus 15 is equal to a 0, not y, is equal to a 0. So that's where we are now. Are you okay with what I've explained, Mr. Levy?
Yes, sir.
All right, wonderful. Anyone else with a question for me? Mr. Tembo, do you have any question for me?
No question.
Okay. How about Billy? Do you have any question for me?
No, sir.
Okay. If there's no question, then let's proceed. So right now, it's just a matter of us calculating the quadratic equation. Okay. So how do we calculate a quadratic equation? We first need to factorize. Okay. We first need to factorize. We are going to look for the product, the sum, and the factors. So the product, I said we multiply A times C. A times C. Okay. I've heard the notification. Yes, Billy, your hand is up. Oh, you have already multiplied. Yes, what's our answer? Oh, it's a question.
No, we have -3 and 5.
Okay. Billy, you're too fast. Billy, you've already find the factors. Okay. Okay. You are too fast. Okay. But thank you for that, Billy. Thank you. Okay. And let me encourage everyone, please. As you are solving, please let our mind move. Okay. Let our mind move. You know how mathematics is whatever we are solving on the physical aspect, it's need to start from the mind. Okay? It's need to start from the mind. So today I was actually telling my learners to say, you know, even the Bible says to say, whatever battle that we have, okay, the battle that we have starts from the spirit before it's manifest physically. The same as with numbers. When you see the question, what comes into your mind? If you are enjoying numbers or if you enjoy mathematics, once, thank you very much, Mr. Madam Rachel. Once you see the question, the mind needs to go ahead of you. Okay? The mind needs to start telling you to say, we are now using this concept. We are now using the concept of indices, the concept of this, before you even start solving. Okay? Because remember, if we talk about the spirit, we are talking about things relating to the mind and the soul, okay, coordinating. Have you seen? So now the mind should be there to go before us, before we even start solving. That's how mathematics is. So now a situation where you see a question, what comes into your mind? Ah, I'll fail. I'll fail. Even as you are solving, you have already failed the question. Okay? You've already failed the question. But you can agree with me. Those who enjoy numbers, once you just see the question, okay, before you even solve, the mind will start moving. Okay, will start saying, okay, now we are on this topic. Okay, now we are on this topic. Now on this topic, we are using this rule or this theorem. That's how it works. So now where you have not appreciated the rules, the theorem, how will the mind going to help you? It will be very hard. Even as you are solving, you're going to feel as if you have carried a heavy load with you. But it's not even a heavy load. It's something that you are supposed to enjoy as you are calculating. Okay? So in short, I'm emphasizing on the aspect of us revising, knowing the rules. Okay? Because mathematics is a subject that obeys the rules, the laws. If you don't obey the rules, it means that you're going to mathematical hell. You're going to fail. So we need to appreciate that concept. Okay? So we need to appreciate the concepts in mathematics. Very important. There's no way you are expecting to pass mathematics and you don't know the rules and the laws. No. Even on this planet Earth where we live in, each society, each country has their rules and laws. Even the Bible, there are laws there that we need to obey. So even in mathematics, guys, let's try to invest knowing the rules. In each topic, what are the rules and laws that you need to follow? Then you'll be home and dry. So now, when we are factorizing a quadratic equation, the first rule says that we need to know the product. The product, which is P, we multiply A times C. A is a coefficient of x squared, so which is a 1, times C, it is negative 15, which is equal to negative. So if we multiply 1 times negative 15, the answer is negative 15. So remember, what I'm doing right now, once you practice this, there's no need of doing this. We can just go direct as Bill has highlighted. Okay? Would have just gone direct and substituted and enjoy our calculation. Because this part, what we are doing here, let me use a red. This what we are doing here has got no mark. Has literally no mark. So if we knew the concept here, I would have gone direct. Okay? But let's go and appreciate the concept. So that when that time comes, when you are alone communicating with the exam paper, we will be able to enjoy the calculations. Okay? So now I'm saying A times C, where A is 1, C is negative 15. And then we say 1 times negative 15, the answer is negative 15. And then we come to sum. We said sum is a coefficient of B, okay, which is a 2. So sum, it is a 2 there. And then factors, we said we need to look for two numbers, okay? Those two numbers, when you multiply them, they need to give us negative 15. When we add or subtract, they need to give us a 2. So when we are interrogating or looking for those numbers, we first need to ask ourselves to say, what are the factors of our product? The factors of 15. So the factors of 15, you can agree with me to say there is 1. Okay, we do this. There is 1. So this one will go hand in hand with 15, of course, because 1 times 15 is 15. Okay, there is also 3. So 3 will go hand in hand with just a minute, let me raise this. So 3 will go hand in hand with 5. Okay, because 3 times 5 is 15. So these are the only factors of 15. Now remember to say we need to look for two numbers. So it's either the first set or the second set. Now these two numbers, when you multiply them, the answer needs to be a negative. Now since the answer needs to be a negative, this simply entails to say one of the factors needs to be a negative, not a positive. Okay? One of the factors needs to be a negative. They are not all supposed to be positives, because if I told they're all positives, then the product will be a positive. But we need to have a product which is a negative. So now we need to actually try and error, okay? Where we put a negative here, we say negative 1 times 15, the answer is negative 15. How about when we say negative 1 plus 15, is it going to give us a 2? No, because it will be a 14. Okay, so now moving forward, since we're just revising, okay, let's go to this set. With this set, when I put a negative here, I'll say negative 3 times 5, the answer is negative 3. Then negative 3 plus 5, the answer is positive 2, which is the sum which is here. So mean that our factor is -3 and 5. So this same factor, I said we need to express them in form of the variable or the letter that we are having. Or in short, we just multiply them with the variable which is x, where we say -3 times x, the answer is -3x. And then 5 times x, the answer is positive 5x. So this expression here will now bring it here. Where there's 2x, we shall remove these 2x and put -3x plus 5x. When I substitute, we are going to have x squared minus 3x plus 5x minus 15. Let me write properly 5x here. So plus 15x minus, okay, minus 15. So we have x squared minus 3x plus 5x minus 15 is equal to a 0. So with what I've explained so far, is there anyone with a question before we jump into the factorization part? Is there anyone with a question for me? If not, just factorize. So we factorize them the group input of course. Okay? The first two, the common factor there is x. Then we open bracket, x into x, the answer is x minus 3 plus even here we have 5, which is a common factor. When we divide, we are going to have x minus 3 instead is equal to 0. And then here I said we need to check that whatever is inside here is also the same as that side there. If I thought that different, just not to say your calculations are wrong. Maybe your factors are not correct. So having achieved this, then we'll take whatever is outside, we bring them together. So we'll say x plus 5. And then what is inside here, we'll just write 1, x minus 3 is equal to 0. So it means that we have factorized. Now our aim is not to factorize, but to solve the equation. So we'll say, therefore, we are going to have x plus 5 is equal to a 0, or x minus 3 is equal to a 0. Then we just correct the like terms. So mean that we're going to have x is equal to -5, or x is equal to, just try to raise this up, or x is equal to positive 3. So these are the values of x that we have calculated. Okay? Now, are we supposed to end here? No. We are not supposed to end here. Remember, we are not looking for the value of x, but the coordinate of b, where we are also calculating the coordinate of a. Okay? So now we need now to come up with a decision here between coordinate a and coordinate b. Which one is going to have -5 and which one is going to have positive 3? Let me go back to the question. Okay, this is the diagram here. And then we are found to say x is equal to -5 and x is equal to 3. So now it's a question. Yes, Billy.
-5 it will be on A, and then +3 it will be on B.
Very good. Very good. Okay. So -5 will be on A because we said A has the negative x values. So A will be -5, 0. B will be +3, 0. This is B. Like that. Mean that, and then now, since we are looking for, the question is saying find the coordinate of B and C. So you even conclude to say, therefore, okay, B, the coordinate of B is 3, 0, and then C is 0, negative 15. Remember this, you need to write it on the underlined space given. Okay? They'll give you where to insert your answers, the space. That's where you're supposed to write this. Yes, Billy, your hand is up.
Yes, I may have a question. When finding the factors, we said that it's a negative 3, 5.
Mm-hmm.
And then, what if we swap? We say, we start with the when we substitute in the equation, we remove this one to negative 2x,
Mm-hmm.
and then we start like we say 5x minus 3x.
Okay.
Is it the answer going to be like it will be wrong, or maybe I don't know?
Okay. I've gotten your question, Billy. I've gotten your question. Actually, B, the answer will be correct because addition obey commutative law. Okay? When we are adding something, regardless of the order, if we say 2 plus 3, the answer of 2 plus 3 is the same as 3 plus 2. Even if we say 2 minus 1, the answer of 2 minus 1 is the same as negative 1 plus 2. It's the same answer. So maybe, in a nutshell, let me do this. Remember, Bill is interrogating about this stage. So let me do this, bring it down here. So we'll have x squared. Instead of writing negative 3x plus 5, I'll write it plus 5x minus 3. Okay? And then we have minus 15 is equal to 0. So I have swapped them. So remember that as you are swapping them, the sign need to remain, okay, to the appropriate term. Very important. So we'll group them now. Factorize 2. So we'll say x, and then we'll say we have x plus 5. And then here, what is common is negative 3. Okay? Then we have x power 5 as well, plus 5 is equal to 0. So as you can see, x plus 5 is common. So whatever it's outside, we'll bring them together. So we are going to have x minus 3, and then x plus 5 is equal to a 0. Okay? So at this stage where we have reached, Billy, let me do this. Let me try to minimize this. Let me say is equal to this side. I didn't write it properly. Is equal to a 0. So this stage, it's the same as this stage. Hope you have seen it. These two, they are one and the same. Because after this, we'll just say x minus 3 is equal to a 0, or x plus 5 is equal to a 0. Then when you create the like terms, you're going to have x equal to 3 or x equal to negative 5 there. Yes, Madam Rachel, your hand is up.
Sir, for me, the mistake I also made, I wanted to ask the same question Billy has just asked. Now, in my situation, I had to put negative 5 and then positive 3. So my answer came out to be x plus 3 and then x minus 5. So in such cases, was my answer wrong at first? Because I had to do the calculation before you calculated to see if I'm able to do it.
Okay. So, to respond to your question, Madam Rachel, whether your answer was correct or wrong, I want to ask you a question. The stage, at this stage, remember this stage where whatever is inside here should be exactly the same as the other one, okay? Whatever is inside the bracket. So now my question is, what was inside your bracket? Was it exactly the same or it was not exactly the same?
It was actually the same.
It was the same.
But it was the same, but I just made a mistake on the, instead of putting negative 3, I had to put positive 3. So inside I had x plus 3x, and then outside there was x minus 5. And then the other side I had the x plus 3. So inside I had the same values.
Let me just write it down, okay?
Yes,
You had
sir.
to?
I had x,
Mm-hmm.
open bracket,
Mm-hmm.
and then I had x plus 3x.
Plus 3x.
You close?
Plus
No,
3x.
sorry. No, just plus 3, sir. Sorry.
Uh-huh.
And then close,
Uh-huh.
and then had negative 5,
Mm-hmm.
open, x plus 3, and then close.
Okay. Let me
Yes, sir.
understand. Let me understand what was on top here.
On top, I
Mm-hmm.
had 3x, had x squared.
X squared.
Yes, sir.
Mm-hmm.
Plus 3x plus negative 5x minus 15 equals to 0.
Okay. I've
Yes,
seen
sir.
now. I've seen where you made a mistake. Okay.
Yes, sir.
I've seen where you made a mistake. Because this question that you are solving is not the question that we are having. Okay?
Oh, okay.
Yes. The question that you are solving is this. You are solving the question which is x squared. And then what is 3x minus 5x? Are you able to help me with the answer, Madam Reka? 3x minus 5x?
That will give me, is it negative 2x?
Negative 2x. Negative 2x
Yes, sir.
minus 15 is equal to 0. So this is the question that you are solving. But
Mm-hmm.
what is the question? Our question that we are solving. Instead of negative 2x, we have what?
We have positive 2x.
Positive
That's
2x.
why I made a mistake, sir.
Yes.
Yes.
So that's where the mistake
So that
was.
so that's the reason I'm asking. So if in a situation like that, which means my answer will be wrong, right?
Yes, it means that your answer will be wrong.
All right. Thank you very much, sir.
So it means that the caution need to come when you are assigning the signs to the factors. You need to be careful there as you assign the signs to the factors. Be careful on that aspect. And then Billy, I saw your hand. Was it a contribution? You wanted to contribute? Sorry,
Yes,
or to
sir.
yes, yes, Billy.
No, you have answered. It's okay.
Oh, okay, okay. Thank you very much, Billy. We appreciate it. Okay. And let's see if at all there's any other question, clarification. Feel free. Okay. If not, let's move to the other part of the question. What is the other part of the question saying? So the other part of the question saying we need to find the minimum value of y. So the minimum value of y, this is the turning point, the y coordinate of the turning point. Okay, remember they can ask you to find the maximum value or the minimum value of y. Okay, which is the y value of the turning point. So here I showed you two methods last time. Okay, two methods. So now, right now, I'm just going to use one method. Okay, just going to use one method right now, where we shall first find the method which I'm going to use. I want to use a method that can help us to know the line of symmetry and the minimum value. In short, that can help us know the turning point. Just in case next time or other papers they ask you to say, calculate the turning point. So that's the method which I'm going to use. Okay? So remember with the turning point, we have the x value, comma, y value. Okay? Let me do this. So I'll say turning point. Just a minute. So turning point, of course, it's in the form of x comma y, where this x has a special name. It is also known as the line of symmetry. Okay, the line of symmetry. And then this y has also a special value or name, which is the minimum, or the maximum, the maximum value, depending with the type of a quadratic which has been brought to you. So now they want us to know the minimum, the value of y. So I'll use a method that will help us know the turning point. So to find the value of x here, we use the formula x is equal to negative b over 2a. Of course, for the minimum, there is a formula that you can go direct. Hope you still remember that formula. Okay? So now, since I'm using this method, x equal to negative b over 2a, remember the quadratic equation is y is equal to x squared plus 2x minus 15. So in this question, we need to identify the value of b. Okay? So the value of b, it is a 2 over, we have 2 times the value of a, which is a 1. Okay? So mean that we are going to have negative 2 over 2, which is negative 1. So which is negative 1. What does this entail? This also entails to say the line of symmetry, the equation of the line of symmetry is x is equal to negative 1. Okay? It's the equation of the line of symmetry, which is also the x value of the turning point. Now, to find the y value of the turning point, okay, if we are using this method, what we need to do is we just need to put where there is x, we'll put 1 here where there is x, and here we'll put negative 1 where there is x. And then we just find the value of y now. So we'll say y is equal to negative 1 squared plus 2 times negative 1 minus 15, like that. Of which negative 1 squared, the answer is 1. Then plus 2 times negative 1, the answer is negative 2 minus 15. So we have 1 positive times negative, the answer is negative. Okay, so we'll write negative 2 minus 15. Remember, we are looking for the value of y. So we'll say y is equal to 1 minus 2, the answer is negative 1, minus 5, the answer is negative 6. So in short, the turning point here, the turning point is negative 1. The x value we said is negative 1, so negative 1 comma negative 16. This is the turning point. Where I said negative 1 represent the line of symmetry. Negative 16 represent the minimum value. So now, since we are looking for the minimum value, I would say, therefore, so use this if at all the question says state the turning point. This is your answer for the turning point. But since you are looking for the minimum value, so we'll say the minimum value is y is equal to negative 16. So this is the minimum value. Okay? This is the minimum value, which is y is equal to negative 16. Any question for me? Any question for me? Yes, Madam Faustina?
No, sir, it's not a question, but if you could try to remove the board, I didn't write what you
Okay.
were explaining.
Give me feedback up to this stage. Madam Faustina, give me feedback. Is it up to this stage? Madam Faustina?
Yes, sir.
Okay. All right. You can write. You can write. Update me when you are done. Okay, she's done. And let's see if at all there is someone with a question. Anything? Someone with a question for me? Anyone with a question for me? Have we understood the concept? Are we okay?
So just a question.
Yes.
So is there another method that you're able to go direct, like solving the minimum value
Yes.
apart from?
Yes. There is a formula that we can utilize. There's a formula that we can utilize. Who can remember the formula, guys? Madam Wanida, what's that formula? Yes, Billy?
It's negative open bracket b squared minus 4ac close, and then over, is it over a, over 4a.
Okay. Have you heard that, Madam Rachel? Negative b squared. You can reset again, Billy. That's what you can write.
Okay, negative open bracket b squared minus 4ac close, and then over 4a.
All right, thank you.
Okay. So with that formula, you'll be able to go direct to find whether it's a minimum or the maximum value. Okay. Since there's no any other question, I think we can go to the last question so that we can conclude this. Okay. So trivial graph is always the last question. Okay. Trivial graph. What are we supposed to know about trivial graph? So our sketch, remember this is just a sketch. Sketchy. Net. Okay. So since you have this question, I'm just drawing the skeleton, sketching the skeleton here, of which the information, let me summarize the information on top. Okay. So it says the following diagram is a speed time graph of a car. The car starts from rest and accelerates uniformly at 3 meters per second in the first 4 seconds. So in these 4 seconds, the first 4 seconds, the car accelerated at 3 meter. Let me write it here. 3 meter per second square in the first 4 seconds. Okay? Until it reaches the speed of v. This v which is here. Okay, it's then covered this constant speed for 8 seconds. So from 4 to 12, we have 8 seconds because 12 minus 4 is 8 seconds. Okay, then it finally comes to rest at 2 seconds here. So the first question is saying find v, the value of v. Okay, the value of v. So we need to appreciate how to find the value of v, which is question A. So to find the value of v, remember they have given us two things. Okay, this v, it is our final velocity, and we have the acceleration here, and we have also the time there. So this stage we can borrow the concept of physics, under physics. If we don't want to borrow the concept of physics, we can also deal with the concept of mathematics under coded geometry. Because do you know that acceleration is the same as gradient? Yes. Acceleration is the same as gradient. Okay? So meaning that if we want, we can use the concept of coordinates, or if you want, we can use the concept under physics. So which one do you prefer we can use? Anyone to view out? What do you think? The concept under physics or the concept under mathematics? Yes, Madam Rachel?
Under physics, it's easier.
Okay. Under physics, we are saying acceleration is equal to, okay? So acceleration is equal to v minus u over t. Okay? So acceleration is equal to v minus u over t, where v is a final velocity, u is a initial velocity, t is a time taken. So here we are looking for the value of v, which is the final velocity. Initial velocity, remember to say, the question is saying the car, this vehicle, or this body started from rest. So mean that the value of u, it's a 0. The value of t, it's a 4. The value of a, it is what? Acceleration, which is a 3. So we just do a simple substitution here. Okay? So where we say 3 is equal to v minus 0 over 4. We need to appreciate that part. Okay? We need to appreciate this. Where now, I think we can simplify the numerator. Okay? V minus 0. V minus 0, the answer is just a v over 4. Then we'll just cross multiply. Okay? We'll cross multiply. When we cross multiply, what are we having? Okay? When we cross multiply, what are we having? So we just need to multiply what is 3 times 4. And the answer is a 12. Okay? So 12 is our final answer. We need to appreciate that. 12 is our final answer. And let's see if there's a question for me. Remember also the units, very important, is 12 meters per second. If you leave out the units, it means that you are calculating something else. Okay? So V is equal to 12 meters per second. Madam Maria, I saw a hand.
What if we use the mathematical method?
The mathematical method, Madam Maria, is where we just need to appreciate, say, acceleration is the same as gradient. Okay? If acceleration is the same as gradient, then the coordinate here at the origin, we know it is 0, 0 at the origin. 0, 0. Okay? That is the coordinate at the origin. Then the coordinate here, where there is v. So the x coordinate is 4. The y coordinate is v. So mean that we say we have 4, v. Okay? So now since we have 4, v, and our gradient, it is 3, then let's find the value of v. Where I will say we need to say gradient is equal to y2 minus y1, everything divided by x2 minus x1. Okay? Where we know to say the gradient is 3 is equal to, okay? And then we just need to make a choice to say, I want this coordinate to contain my 1, this one to contain the 2's. So I'll take this 4, v to contain the 2's. So mean that I'm going to have v. So v minus a 0. V minus a 0. And then we are going to have 4 minus a 0. 4 minus a 0. So in short, where we have reached now, it's the same as this stage. The rest is the same. I don't know whether you are you're able to see that you have reached at the same stage, because v minus 0 is v, 4 minus 0 is 4. Madam Maria, are you okay with what I've explained?
Yes, I am okay. Thank you.
Anyone else with a question for me? Anyone else with a question for me? Billy, you're okay? If there's no question, I think let's proceed. We go to B. B is saying we find the average speed for the first 12 seconds. So average speed for the first 12 seconds. So we need to acknowledge the formula for speed. What do we do when we are calculating speed? So we know to say speed, okay? The formula for speed is equal to distance over time. Distance over time. We need to appreciate that, okay? So in this situation, what we have, the question is saying the average speed for the first 12 seconds. So mean that time we have is 12. Time we have is 12. What we don't have is d. So we first need to calculate the distance covered. So under triangle graph, the distance is just the area under the graph, the area under the curve given. So mean that we need to calculate this area here which I'm shading. Okay? Because that's where 12 seconds is ending from. We are not going to go up to t, no. Okay? So this area which I'm shading here, that's the area which we need to calculate. As you can see, I said we need to calculate the area under the graph. So this shape is a trapezium. It's a trapezium. So the formula for the trapezium for the area, will say area is equal to. So we need to appreciate this, and we need to know the formulas for the area of different shapes. And the common shapes that you can be given is either trapezium, rectangle, a square, and a triangle. These are the common shapes that we need to use. Okay? These are the common shapes that they are examinable. Okay? So half a plus b times h. It is the area of a trapezium. Where a, it is 8. Okay? A, it is 8 between 4 and 12. 4 and 12. This distance here, this is the value of a. This distance here, this is the value of a, which is also corresponding to 4 and 12. So this is the value of a. And then for the value of b, it's from here up to here. The whole base, this is b. For the h, it's the value of v, which we have calculated already. So let's just do the simple substitution first. So we have 1 over 2 there. Okay, and then we have open bracket, the value of a, which is 8. And then the value, okay, let me first write 8. And then the value of v, it is 12. And v, and our height, it's v, which is a curve again, like that. If we simplify this, 2 and 12 can cancel each other, okay, to give us a 6. So meaning that, what are we going to have? We are going first to add 8 plus 12. When you add 8 plus 12, the answer is 20 times 6. So 20 times 6, of which the answer is 120. 120 meters. Okay? So 120 meters. You can agree with me. Because 2 times 6 is 12, and then we have a 0. So 120 meters. So now this area, it's also the distance that we have calculated. Because I said the distance, it's the same as the area under the graph. So now we just need to substitute now. Where there is d, we shall put 120. Initially I said we don't know d, now we have calculated. Time we know it's 12. So now we'll say therefore, let's finish up with this formula here. Okay. Remember, we have been given, we have calculated to say our distance is 120. Okay, our distance is 120. After knowing to say our distance is 120, what is the time taken? Time taken, I've said the time taken is 12 seconds. Okay, so now we'll just divide these 12 seconds into 120. When we divide, you can agree with me to say, because the 12, they can cancel each other. Okay, the 12 can cancel each other, and the answer will be a 10. The answer will be 10. Let me do this. So the answer will be, just a minute. So the answer will be 10 meter per second. We need to appreciate this. The answer will be 10 meter per second if you divide properly. Okay. 10 meter per second. So having done this, let's now conclude with the last question. Let's now conclude with the last question. So the last question is saying, we find the value of t. The value of this t here, value of t if the speed at t is equal to 14 is 4 meters per second. I'm sure a lot of people have this challenge on this question, but it's very simple. The only concept that you need to know under this is similarity and commonwealth. It's a great topic. Okay. So they are saying the value of t if the speed at t is 14. So remember, we have 12 seconds and we have t. So mean that there's another time here between. There's another time here between. Okay? And that time they have said it is the value of what? 14. The value of 14. So what I'll do is I'll deliberately just remove this part. Let me do this. Use this color. I'll deliberately just going to remove this triangle. Okay? That's what we're going to do. So this is a triangle where we have 1, I want you to follow me clearly. We have this is a 12. Okay, this is a 12. And also we have been given to say here we have also a 14. Okay, we have 14 seconds because they are saying the value of t, if the speed at t is equal to 14, is 4 meters per second. Okay, so we have 14 here. And then at the end there, we have a t, which is what we are looking for. We have a t, which is what we are looking for. Then after this, we know to say on top here, we have a v, and the v was a 12. Okay, the v was a 12. The v was a 12. And then remember to say this 14 seconds is corresponding to what value of speed, which is 4 meters. Because the question is saying the value of t, if the speed at t is equal to 14, is 4 meters per second. So mean that from here up to here, we have 4. Okay? We have 4. So in short, this is similar triangle where I want you now to follow me as I'm summarizing this. From here up to here, okay, from here up to here, we have a 12. We have a 12 from here up to there, as I've explained. Then from here up to here, we have a 4. This is a 4. Now, what is the concept of similar triangle mean or says? Okay, this is where we compare sides of similar triangles. So here in this shape, we have got two triangles. There is a smaller triangle and a bigger triangle. The smaller triangle is passing through T, 14, and going up by 4. The big triangle is C, again T, 12, going again where there is 12 there. So we shall first compare the bases. Or maybe let's start with the height. Okay? The height we have 4. So we'll say 4 over 12. I've started solving now. 4 over 12. This 4 over 12 should also correspond to, okay, is equal to the base of the smaller triangle here, which is from here up to here. This is t minus 14, the difference which is there, t minus 14. Okay, so I will say t minus 14. Okay, over down there we are going to have t minus 12. Just before I continue, is there anyone with a question for me? Because after this, it's just a matter of us cross multiplying and then we find the value of t. Yes, Madam Rachel.
So where is the 4 coming from? I'm a bit behind.
The 4, it is in the question we have been given to say the value of t, if the speed at t is equal to 14, is 4 meters per second. So this is a situation where if you go to the diagram, okay, this diagram, they are saying the speed at 14 seconds is 4 meters. Okay, let me do this. So here, so the speed when you go up there, okay, when you go up there, so this speed, when you go like this is where the 4 meters per second is. Have you seen that? Because they are saying the value of t, if the speed at t is equal to 14 is 4 meters per second. So mean that the height here is 4, which is this 4 there. I don't know. Have you understood that part, Madam Rachel? Okay. Are we all okay? Madam Anida, are you okay with what I've explained?
Yes, I'm okay.
Okay. So meaning that now we just need to cross multiply. But of course, if you want, you can reduce this. You can reduce because there's a number that can go into 4 and 12 before you even cross multiply. You can reduce if you want to. So, but if you want, we can go ahead and cross multiply. If you want, you can reduce it. But since this is paper 1, I think it's better we reduce so that we avoid multiplying bigger number. So we say 4 into 4, it's 1. And then 4 into 12, you can agree with me to say it is a 3. Okay? It's a 3. And then maybe let's do this. How many have followed my calculation so far? Or maybe some of you are lagging behind. Okay. What we'll do is, I don't know whether you have observed, I'm having a poor network. That's the reason why my pen is not that active. But try to cross multiply this, okay, and calculate the value of t. However, tomorrow we are also meeting. Maybe I shall start on this question. What do you think about that? So I shall start on question C. Okay, I shall start on question C. But from where we have ended here, try to cross multiply on your own and calculate the value of t. Unless if at all someone has done that already, they can help us with the value of t. Anyone who has already cross multiplied and everything? If not, we'll start on this question, specifically question C. Okay, and then we'll move on the other aspect. Okay, so that's how we are going to move. Otherwise, it has been an honor having you once again. So tomorrow, let's not forget, we have a lesson so that we can also start with paper 2. Then I don't know whether I can maybe try and subdivide you into those groups so that we can go through maybe the paper 2 questions and then we start revising. Although some of you are not even solving, that's the only advantage. But the more reason why I created those Masabu groups is for you to first go through the paper, okay, where you discuss with those friends in that small group. But as I'm teaching, it will be very easy for you to understand. However, we shall see what we can do. Otherwise, thank you very much, guys. Yes, Billy? Yes, Billy. Your hand is up.
Okay. Oh, sorry. I didn't unmute to speak. Sir, I'm having this question. It's about maths. Now, I don't know if my colleague lied or what. I don't know. What is solved doesn't make sense. Okay. It's saying solve the equation. There is a 10x is equals to 0.001.
Okay.
Yes. And then it's saying solve the equation.
Okay. It's just that I'm having a challenge with network concerning my ink. That's the reason why it's not responding fast. But I've already written what you have said. But it's coming slow. I think it's because of network on my end. But that question is very simple. Maybe they try and post it on the group and then I'll solve and then I'll capture it for you.
All right, sir.
All right, guys. Thank you very much. Have a good night. Let's link up tomorrow. Goodbye and bye-bye.